third part of polynomials from grade 9 mathematics. Today we shall study two famous theorems, remainder theorem and factor theorem and their applications. Theorems are prepositions or statements which you have already proved. Therefore, for the theorem there are two parts, statement of the theorem and the proof of the theorem. First of all, let's recall what we have studied in the previous session. In the previous session, we studied the concept of zero and the method to calculate zero of a polynomial. Again, we discussed the point, we discussed the basic operations with polynomials. The value of a polynomial px at x equal a is p of a, and if p of a equals 0, then a is called the zero of the polynomial px. That is, values of the variables for which the value of the polynomial becomes 0 are called the zeros of the given polynomial. Again, to calculate the zero of the polynomial, we have to solve the equation px equal 0. Again, you know that for an nth degree polynomial, the maximum number of zeros must be n. The number of zeros of a polynomial cannot exceed its degree. The next point, basic operations with polynomials. For addition and subtraction of polynomials, we have to collect the like terms and add or subtract the numerical coefficients of the like terms. Then for multiplication of polynomials, to get the numerical coefficient of the product, if the terms are monomials, that means monomial by monomial. In that case, to get the numerical coefficient of the product, we have to take the product of the numerical coefficients of the monomials, and to get the variable part of the product, we have to multiply the variable parts of the monomials. In this case, we have to follow the laws of indices, that is x raised to m into x raised to n equal x raised to m plus n. Again, to multiply binomial or a polynomial by a monomial, we have to apply the distributive law of multiplication over addition. Then the next point, the division of polynomial. If you divide a monomial by a monomial, that is if the dividend and divisor both are monomials, then to get the numerical coefficient of the quotient, or we have to divide the numerical coefficient of the dividend using numerical coefficient of the divisor. Again, to get the variable part of the quotient, we have to divide the variable part of the dividend using variable part of the divisor. Again, we have to apply the laws of indices, that is x raised to m divided by x raised to m equal x raised to m minus n. We also studied the long division method for the division of a polynomial by another polynomial. In the long division method, we studied two methods. The first one, taking both the variables and the coefficients, and the second method, long division by taking only the coefficient. I think that you too feel that the second method, taking only the coefficient alone, is easier method. Am I right? Then what about your assignment? Could you complete that? Let's start with today's topic. I told you today we are going to study two important theorems, remainder theorem and factor theorem. You know that these words remainder and factor, these terms are related with the division. Yes, you have already studied the division fact also, or division algorithm. What is division algorithm? Dividend equal divisor into quotient plus remainder. Dividend equal divisor into quotient plus remainder. Remainder may be 0. Again, remainder should be always less than the divisor. That is the condition. Remainder can take the value 0, but remainder should be always less than the divisor. This division algorithm is applicable for polynomials also. Consider two polynomials, non-zero polynomials px and gx. Then there exists unique polynomials qx and rx such that px equal gx into qx plus rx. you know that here gx is the divisor and px is the dividend. Qx, Q for quotient, therefore Qx denotes quotient polynomial, and R for remainder, therefore Rx denotes remainder polynomial. Here also we know that this remainder can be 0 or remainder. In this case of polynomials case, remainder Rx may be a 0 polynomial, but the degree of the remainder polynomial should be less than that of the degree of the divisor polynomial. That is the condition. A remainder polynomial can be a 0 polynomial, or degree of the remainder polynomial must be less than that of the degree of the divisor polynomial. If the divisor polynomial is a linear polynomial means degree 1. In this case, the remainder polynomial's degree must be 0. That means that remainder must be a 0 degree polynomial. 0 degree polynomial means it must be a constant. Division algorithm. Dividend equal divisor into quotient plus remainder. When px and gx are two non-zero polynomials, then there exists unique polynomials qx and rx such that px equal gx into qx plus rx, where rx equals 0, or degree of rx should be less than degree of gx. Rx can be a 0 polynomial, 0 means 0 polynomial, or degree of rx should be less than degree of gx. The previous class we discussed the long division method. Find the remainder when y cube plus y square minus 2y plus 1 is divided by y minus 3. Let's complete this using the long division method, taking the coefficients along. Here the dividend is y cube plus y square minus 2y plus 1. We have to check whether the dividend and divisor both are in the standard form. Here they are in the standard form. The first term is a cubic term y cube, then the second term is of degree 2, then the third term is of degree 1, the last term is a constant. Therefore, the terms are arranged in the standard form. Therefore, we can take the coefficients along. 1 plus 1 minus 2 plus 1 divided by 1 minus 3. 1 divided by 1 equal 1. Therefore, 1 into 1, 1, 1 into negative 3, negative 3. 1 minus 1 equals 0, 1 minus negative 3. Negative into negative become positive, therefore 1 plus 3 become positive 4. Bring down the next terms, negative 2 and 1. Now, positive 4 divided by 1 is 4, therefore again we can write positive 4. 4 into 1 equal 4, 4 into negative 3 equal negative 12. 4 minus 4, 0. Negative 2 minus negative 12, again negative 2 plus 12, that is equal plus 10. Again bring down the next term 1. Now 10 divided by 1, that is equal 10. Therefore 10 into 1 equal 10, 10 into negative 3, negative 30. 10 minus 10 equals 0, 1 minus 30. 1 minus negative 30, that means 1 plus 30 become positive 30. Your question, find the remainder. Therefore, answer remainder equal plus 30. Here we got the remainder as plus 30. We got when we divide y cube plus y square minus 2y plus 1 using y minus 3, the remainder as 31 and the quotient as y square plus 4y plus 10. Now see, we are going to calculate the value of py at y equal 3. Let's try to solve. Py equal y cube plus y square minus 2y plus 1. Calculate P3. To get P3, we have to substitute the value 3 in place of y. P3 equal 3 cube plus 3 square minus 2 into 3 plus 1. That is equal 27 plus 9 minus 6 plus 1. 27 plus 9, 36. 36 plus 1, 37. 37 minus 6. That is, we can write it as 27 plus 9 plus 1 minus 6. 27 plus 9, 36 plus 1, 37 minus 6. That is equal to 31. It's very clear that when we divide py using y minus 3, the remainder we got as 31. Here also, when we calculate p3, we got the same value 31. That means when we divide py using the divisor, when we divide py using y minus 3, the remainder 31, that is also equal to the value of the polynomial py at y equal 3. Yeah, that means without doing the normal division process, we can calculate the remainder when we divide a polynomial using a linear polynomial. Here y minus 3, y minus 3 is a linear binomial, its degree is 1. This remainder theorem is applicable for linear polynomial. That means the dividend may be a polynomial, but any polynomial, but divisor must be a linear polynomial. Linear polynomials are polynomials of degree 1. That is the only point we have to take care. Now let me give the statement of remainder theorem. Remainder theorem is the easiest method to calculate the remainder without doing the normal division. Okay, let Px be a polynomial of degree greater than or equal to 1 and a be any real number. When we divide Px using x minus a, the remainder will be equal to P of a. Px be any polynomial of degree greater than or equal to 1 and a be any real number. If we divide Px using x minus a, the remainder is equal to P of a. This is known as remainder theorem. Let Px be any polynomial of degree greater than or equal to 1 and a be any real number. If Px is divided by x minus a, then the remainder is equal to P of a, P of positive a. Now I told you for the theorem there are two parts. Statement of the theorem. This is the statement of remainder theorem. Now the next part we have to prove that. Here you see that x minus a is a linear polynomial. X minus a is a linear polynomial. That divisor is linear. Therefore, degree of the remainder must be less than 1. Degree of the remainder less than 1 means remainder must be either a zero polynomial. That means either 0 or it must be a constant polynomial, 0 degree polynomial. Therefore, a remainder can be equal to 0 or it must be a constant polynomial. That means a constant value. Okay, let's try to give the proof. According to division algorithm, Px equal dividend equal divisor into quotient. Here we took x minus a as the divisor. Therefore, x minus a into the quotient must be qx. Qx plus, I told you, remainder Rx, but this reminder's degree, remainder polynomial's degree must be less than that of x minus a. Therefore, remainder must be constant. We can say it as R. Now, Px equal x minus a into Qx plus R. Just calculate P. That is value of this at x equal a. What will happen here? Instead of x, if you put a, it will be a minus a into q of a plus r. You know that a minus a equals 0. Therefore, this is equal 0 plus r, that is equal r. It means that when we divide Px using x minus a, the remainder r equal P. that is a remainder equal or that is equal P of A. Remainder equal P of A. I hope it's clear to you. Remainder theorem states that when we divide Px using x minus a, the remainder will be P of positive A. See, x minus a is the divisor. We have to solve that divisor equals 0. Let us solve the equation divisor equals 0. See, if x minus a is the divisor, we have to take x minus a equals 0, therefore x becomes a. Like that. Suppose ax plus b is the divisor. X plus b, you know that x plus b is the general form of linear polynomial. Then x plus b equals 0. We have to solve the equation x plus b equals 0. If we divide px using x plus b, then what will be the remainder? To check that, first of all, we have to solve the equation. The divisor polynomial equals 0. That is, ax plus b equal 0. That means ax equal negative b and x equal negative b by a. In this case, the remainder will be p of negative b by a. P of negative b by a. If we divide px using x plus b, the remainder will be p of negative b by a. Px divided by ax minus b. Then what will be the remainder? We have to solve the equation ax minus b equal 0. That is, ax minus b equal 0. Ax equal b. Therefore, x equal b by e. In this case, a remainder equal p of positive b by e. See, px divided by x plus e. You know that we have to take x plus a. We have to solve the equation x plus a equal 0. X plus a equal 0. Therefore, x equal negative a. In this case, a remainder equal p of negative a. If we divide px using x plus b, the remainder will be p of negative b by a. If we divide px using ax minus b, the remainder will be p of b by a. If we divide px using x plus a, the remainder will be p of negative a. Px divided by b minus x. Then what will be the remainder? Here also we have to solve the equation this divisor equal 0. That is, b minus ax equal 0. If we shift this b to right, we will get negative ax equal 0 minus b. That is, negative ax equal negative b. Therefore, x equal b negative b by negative b. That is equal b by a. Therefore, in this case, the remainder equal p of b by e. Is it clear to you? If a polynomial px is divided by x plus a, then the remainder is p of negative a. If a polynomial px is divided by ax minus b, then the remainder is p of b by a. If a polynomial px is divided by ax plus b, then the remainder is p of negative b by a. The fourth one, if a polynomial px is divided by b minus ax, then the remainder is p of b by e. Now let's go through some examples. Divide the polynomial x raised to 4 plus 3x cubed minus 2x squared plus x plus 10 by x plus 2 verify the remainder by using the remainder theorem. That means, first of all, we have to divide the polynomial using the long division method and find the remainder. Then we have to use the remainder theorem to find the remainder. Then we have to check whether both of them are equal. That is the meaning to verify. Okay, shall we start? To do the long division method, I am going to take the coefficients alone. Here also is the x raised to 4 plus 3x cube minus 2x square plus 6 plus 10. It is in the standard form. Therefore, we can collect all the coefficients. The divisor also x plus 2 is also in the standard form. Therefore, first of all, taking the coefficients alone. 1 plus 3 minus 2 plus 1 plus 10 divided by x plus 2, therefore 1 plus 2. Now, the first term of the dividend, that is 1. First term of the divisor also 1. 1 divided by 1 is 1. 1 into 1, 1, 1 into 2, 2. Therefore, 1 minus 1, 0. 3 minus 2 is positive 1. Bring down the next terms, negative 2 plus 1 plus 10. Again, the first term here, the next part is positive 1. The first term of the divisor also positive 1. Therefore, 1 by 1, you can plus 1. 1 into 1, 1, 1 into positive 2, 2. 1 minus 1, 0. Negative 2 minus positive 2. That means negative 2 minus 2. That is equal to negative 4. Bring down the next terms. Now the first term of this term is negative 4. Here it is 1 itself. Negative 4 by 1 is negative 4. Negative 4 into 1, negative 4. Negative 4 into positive 2 is negative 8. Negative 4 minus negative 4 equals 0. 1 minus minus 8. That means 1 plus 8. That is equal to plus 9. Bring down the next term plus 10. Now 9 by 1 is 9 plus 9. Positive. 9 into 1 is 9. 9 into 2 is positive 88. Again, 9 minus 9, 0. 10 minus 18 is negative 8. That means we got the remainder as negative 8. Now we have to verify the theorem. That means using the remainder theorem. What will be the remainder? Using the remainder theorem, you know that since x plus 2 is the divisor, the remainder should be p of negative 2. Let's calculate p negative 2. Px equal x raised to 4 plus 3x cube minus 2x squared plus 6 plus 10. P of negative 2. That is negative 2 raised to 4 plus 3 into negative 2 cube minus 2 into negative 2 square plus negative 2 plus 10. Negative 2 raised to 4. Negative 2 raised to 4 become 2 into 2, 4 into 2, 8 into 2, 16. The product must be positive 16 plus 3 into negative 2 cube is negative 8. Minus 2 into negative 2 square is positive 4. Positive into negative, negative 2 plus 10. Again, 16 minus 24 minus 8 minus 2 plus 10. We have to collect the positive terms first of all. That is 16 plus 10 minus 24 minus 8 minus 2. 16 plus 10 is 26 minus 24 plus 8, 32 plus 2, 34. 26 minus 34 is negative 8. Yeah. We got the remainder also negative 8. P negative 2 also negative. That means the remainder theorem is verified. question. If the polynomial x cube plus 4x square plus 3x minus 4 and x cube minus 4x plus a left the same remainder when divided by x minus 3, find the value of a. Here there are two polynomials. We can name them as px and g's or px and qx. See, the first one, px. Px equal ax cube plus 4x square plus 3x minus 4. When we divide this polynomial using x minus 3, the remainder, you know that since x minus 3 is the divisor, the remainder must be p of positive 3. Therefore, when we calculate P3 equal a into 3 cube plus 4 into 3 square plus 3 into 3 minus 4, that is equal 3 cube, 3 into 3 into 3, that is 27. You can write it as 27a plus 3 square is 9. 9 into 4 become 36 plus 3 times 3, 9 minus 4. Here, you know that addition of terms, we have to collect only the like terms. Here only one time having a, therefore it is 27a. Again, 36 plus 9, 45. 45 minus 4 is 41 plus 41. The second case is given that gx equal or qx equal x cube minus 4x plus a. Okay, let me take it as gx. Gx equal x cube minus 4x plus a. If you divide gx using x minus 3, you know the remainder should be g of positive 3. That means g3. We have to calculate g3. That is equal 3 cube minus 4 into 3 plus e. We will get g3 equal 3 cube equal 27 minus negative 4 into 3 equal negative 12 plus e. 27 minus 12 is 15. 15 plus a. Just check the question. It is given that the remainder when divided by x minus 3 are equal. When we divide these two polynomials using x minus 3, the remainder will be equal. To find the value of e. From the question it is clear that P3 equal G3. P3 equal G3. P3 equal 27a plus 41. That is equal G3 equal 15 plus a. To solve this equation, we will shift the positive a to left and positive 41 to right. Then you will get 27a minus a equal 15 minus 41. 26a equal negative 26. Therefore, a equal negative 26 by 26, that is equal negative 1. Therefore, answer a equal negative 1. You know that if the remainder is 0, then the divisor is a factor of the dividend. If the remainder is 0, then the divisor is a factor of the dividend. Factor theorem states that the same part. The remainder is 0, then the divisor is a factor of the dividend. That is, let px be a polynomial of degree greater than or equal to 1 and a be any real number. If p of a equals 0, then x minus a is a factor of px, and if x minus a is a factor of p of x, then p of a equals 0. Let px be a polynomial of degree greater than or equal to 1 and a be a real number such that pa equals 0. That means remainder is 0. Then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a equal 0. See, x plus a is a factor of a polynomial px if and only if p of negative a equals 0. X plus a is a factor of polynomial px if and only if pf negative a equals 0. Ax minus b is a factor of a polynomial px if and only if pf b by a equals 0. Ax plus b is a factor of the polynomial px if and only if pf negative b by a is 0. Know that when you divide a polynomial using x plus b, the remainder is pf negative b by a. If that remainder is 0 means x plus b is a factor. Same way, if x minus a into x minus b is a factor of a polynomial px, if and only if pf a equals 0 and pf b equals 0. These are the points you have to remember. The last one, x minus a into x minus b is a factor of a polynomial px if and only if pf a equals 0 and pf b equals 0. Without actual division, prove that 2x raised to 4 minus 6x cubed plus 3x squared plus 3x minus 2 is exactly divisible by x squared minus 3x plus 2. Here we can't do the actual division. We have to show that 2x raised to 4 minus 6x cubed plus 3x squared plus 3x minus 2 is exactly divisible by x squared minus 3x plus 2. You know that x squared minus 3x plus 2, we can factorize it using splitting the middle term method. Let's try to solve this question. X squared minus 3x plus 2. This is equal. Know that here 1x squared minus 3x plus 2, splitting the middle term method, the product of two numbers is positive 2 and the sum is negative 3. Product positive 2 and sum negative 3. That means we can split this negative 3x as x squared minus 2x minus 1x plus 2. Now from the first two we can take x as common. Therefore x into x minus 2. Again from the third and fourth term you can take negative 1. Negative 1 into x minus 2. Now it is clear. X minus 2 is common for both terms. Therefore we can take it out. Then the remaining x minus 4. Therefore x squared minus 3x plus 2. X squared minus 3x plus 2 equal x minus 2 into x minus 4. We studied that both this x squared minus 3x plus 2 is a factor means or the given polynomial px is divisible by x squared minus 3x plus 2 means it must be px must be divisible by x minus 2 and px must be divisible by x minus 1. That means both p2 must be 0 and p1 must be 0. If p2 equals 0 and p1 equals 0, we can say that the given polynomial is divisible by x squared minus 3x plus 2. We got x squared minus 3x plus 2 equal x minus 2 into x minus 1. Now we have to check p2 and p1. Px equal 2x raised to 4 minus 6x cubed plus 3x squared plus 3x minus 2. Now P2 equal, since it is x minus 2, we have to take P2. P2 equal 2 into 2 raised to 4 minus 6 into 2 cube plus 3 into 2 squared plus 3 into 2 minus 2. That is equal 2 raised to 4. 2 into 2, 4 into 2, 8 into 2, 16. 16 into 2, that means 32. Minus 6 times 2 cube is 8. 6 times 8 is 48. Again 2 square is 4. 3 times 4 is 12. Plus 6 minus 2. Collect the positive terms. That is equal 32 plus 12 minus 6. Negative 48 and negative 2. Now that 32 plus 12, 44. 32 plus 12 plus 6. Therefore 44 plus 6 is 50. 50 minus 50. 50 minus 50 equal 0. That is, we got P2 equal 50 minus 50 equal 0. That means x minus 2 is a factor of the given polynomial px. Now we have to check p1. Px equal to x raised to 4 minus 6x cube plus 3x squared plus 3x minus 2. We are going to calculate p1. Now 2 into 1 raised to 4 minus 6 into 1 cube plus 3 into 1 square plus 3 into 1 minus 2. Now 1 raised to 4 is 1 itself. Therefore 2 minus 1 cube also 1. Therefore 6 into 1 6. 3 into 1 3 plus 3 minus 2. Collect the positive terms. You will get 2 plus 3 plus 3 minus 6 minus 2. 2 plus 3 5 plus 3 8. 8 minus 8 equal 0. That is P1 equal 0. Since P2 and P1 are zeros, P2 equals 0 and P1 also 0, it's clear that the given polynomial Px is divisible by x squared minus 3x plus 2. Dear students, today we discuss the remainder theorem and factor theorem and their applications. I hope you will be able to solve questions from this section. Please try to complete the assignment. Thank you.